Okay, Assalamualaikum warahmatullahi wabarakatuh, and very good day to every one of you. So today we will continue our lesson still in chapter 4, which is solving the non-homogeneous differential equation, and we still working on the non-homogeneous differential equation, and now we want to try the annihilator approach. Okay, annihilator approach will be used to help us to find the particular solution for our non-homogeneous differential equation. So as mentioned before in our previous class, when we are dealing with non-homogeneous differential equations, is about finding the solution that combine the complementary solution and also the particular solutions. Okay, so we have the final solution of non-homogeneous differential equation as y, but it will be the combination of yc plus with yp, where yc is a complementary solution that we get from the homogeneous part of our differential equation, and yp is the trial solution that we find the arbitrary constant, and we get the yp according to the value of gx on the right side of our differential equation. So today we want to try the annihilator approach for us to help us in finding the yp, okay, the yp of our solution. Okay, so we will see later how this annihilator approach can help us in finding the solution to our non-homogeneous differential equation. Before we go further, let's see the definition of annihilator approach. So annihilator approach have an annihilator operator. Okay, so when we are talking about annihilator approach, means that we are using the annihilator operator. So what is the annihilator operator? If L is a linear differential operator, okay, so L is a linear differential operator with constant coefficient, and F is a sufficiently differentiable function such that when we are using the differential operator and the function of x, we will get the value of 0. Then L is said to be an annihilator of the function. Okay, L is said to be an annihilator of the function. So annihilator of the function usually in the form of differential operator. So before we go further about our annihilator of the function, okay, by using the annihilator approach, we will see first what is the differential operator. Okay, so we want to see what is the differential operator. So the differential operator is in the form of D, okay, where D means that dx, the derivative with respect to x, means that is the derivative of any function. Okay, if you want to find dy dx is actually the derivative of y with respect to x. If we want to write in the form of differential operator, it will be dy. Okay, so this one is called as a differential operator, where you know that D, the capital D here, membawa maksud, okay, dia membawa maksud the differential, the derivative of a function with respect to x, or with respect to the independent variable. Therefore, if you have the second order derivative, which is d square y dx square, this can be transformed into differential operator as d square y. Okay, because we already know that this differential operator means the derivative with respect to x. So if it in the order of 2, means it's a second order derivative. Okay, so from this differential operator, we can transform it into d square dx square. Okay, but for the simplest form of symbol, we use the differential operator. So if you have the second order differential equation, for example, y double prime plus 4y prime plus with 4y equal to 0, okay, we can write this differential equation in terms of d square y dx square plus 4 dy dx plus 4y equal to 0. And we know that this derivative symbol can be transformed into the differential operator, where d square dx square, d square dx square can be written as d square y by using differential operator, plus with 4d, okay, y, because this one is the order one, d dx is equal to d, plus with 4y equal to 0. Therefore, this can be written as d square plus 4d plus 4y equal to 0. Okay, so from here, you will get your... From here, you can get also your roots, okay, which is... From here, you can write this one as d plus 2 to the power of 2y equal to 0. So this part is called as a differential operator of your differential equations. Okay, so the annihilator operator actually use the differential operator, where what is the annihilator operator for each function is what is the differential operator that makes that function become 0. Okay, for example, you have y equal to 2. Okay, so you want to know what is the differential operator that annihilates y equal to 2. Okay, what means annihilates y equal to 2? Annihilator operator will transform the function, okay, annihilator operator will transform the function to become 0. Okay, for example, if you have y equal to 2, okay, then if you differentiate your y, you will get dy dx equal to 2. Means that this one can be written as dy equal to 2. So now what is... Sorry. If you have y equal to 2, okay, you differentiate y dy dx is equal to 0. Okay, so you have the differential operator d on y, which is equal to 0. This means that the differential operator d transform the function y equal to 2 to become 0. Okay, so any differential operator that transform your function become 0, it called as a annihilator operator. Okay, so apa-apa operator yang menyebabkan awak punya equation itu jadi kosong, operator ini adalah derivatif. So berapa kali derivatif yang akan menjadikan you punya function itu kosong, kita panggil dia sebagai annihilator operator. So for this case, d makes y equal to 2 to become 0. It means that the function of y equal to 2 is annihilated by the differential operator d. Okay, let's say if you have y equal to x. You have y equal to x. You differentiate once, you will get dy dx equal to 1. It's not yet 0. You differentiate twice, you will get d square y dx square equal to 0. Okay, now this one is the second derivative that you can write in the form of differential operator such that d square y equal to 0. What is the meaning of this one? It means that the differential operator d square transform your y equal to x to become 0. Therefore, this one is called as an annihilator operator for y equal to x. Okay, kerana dua kali differentiate awak dapat sama dengan kosong. Maksudnya dia punya differential operator adalah d square. So d square is the annihilator operator untuk function y equal to x. Therefore, y equal to x is annihilated by the differential operator d square. Okay, so if question asks you, what is the annihilator operator for the function y equal to 4x square plus 3? What is the annihilator operator for y equal to 4x square plus 3? So you differentiate twice, you differentiate once, dy dx, you will get 8x, not yet 0. Okay, and then you differentiate twice, you will get 8. still not 0, and differentiate again, you will get d cube y dx cube equal to 0. Okay, so when you get equal to 0 means that this one need to be transformed into then a differential operator, which will be d cube y, okay, equal to 0. Therefore, we can say that the differential operator d cube is the annihilator operator that annihilate the function y equal to 4x squared plus 3. Okay, or you can write as y equal to 4x squared plus 3 is annihilated by the differential equation d3. Okay, so what is the annihilator operator? Annihilator operator is the differential operator that transform your equation to become 0 by the process of differentiation. Okay, so class, differential operator can be written, according to the function. Okay, it's differ according to the function. For example, if you have only the polynomial function, your differential operator is in the form of dn. Okay, for example, if you have y equal to 4x to the power of 3 minus 2, okay, 4x to the power of 3 minus 2, how to write the differential operator for this one? You need to know that your equation will be the highest power in your equation will be n minus 1, while your differential operator will be in the form of d to the power of n. Therefore, you need to find what is the value of n. You need to know that whenever you have your equation, the highest power in your equation is always n minus 1. Okay, so n minus 1 is equal to 3. Therefore, your n is equal to 3 plus 1, 4. So, what is the differential operator for this equation? It is d4. Okay, and you can always check, is it true d4 is the annihilator operator that make this equation to become 0? So we can check. Okay, we can differentiate this one once. Okay, we differentiate this one once, we will get dy dx. So this one will become 12x squared minus 0. Okay, and then you differentiate for the second time, you will get d square y dx squared, which is 24x, not check 0. Differentiate for the third time, you have d cube y dx cube, so you will get 24, not check 0, and differentiates again, you will get d fort y dx fort, which is 0. So this one is the annihilator approach, where the function y equal to 4x cubed minus 2 is annihilated by the differential operator d4. Okay, so whenever you have the polynomial equation, okay, you find what is the highest power in your polynomial equation. This one is always n minus 1. Okay, so from this you will get the value of n. So your differential operator is always in the form of d to the power of n. Okay, so you can see the example that we have done previously. So in this polynomial, the highest power that you have in this polynomial is equal to 2. Okay, so 2 will always be n minus 1. So n is equal to 3. Means that the differential operator d3 is the one that annihilate your function. Okay, and you already done it. It's d3. So it is for the polynomial function, where when we have our polynomial function, we need to see what is the highest degree in your polynomial, and it will be always n minus 1. So find the value of n. dn is the form of differential operator for the polynomial function. While if you have your polynomial plus exponential function, okay, means that you have the polynomial plus exponential function. Okay, the differential operator will always be d minus alpha to the power of n. Again, how to get the value of n? You need to see what is the power of your polynomial. Okay, and the power of your polynomial, the highest power is always n minus 1. Therefore, from there, you can find the value of n, and where is alpha? Alpha is in exponent. Okay, so you can form your differential operator. Let's do some example. Let's say if we have, um, let's say if we have exponent 2x. Okay, our y is exponent 2x. Okay, so how can we find the differential operator for the exponent 2x? Okay, from here, you know that if you have the exponential function, you need to have the differential operator in the form of d minus alpha to the power of n. So the first value that you need to know is what is the value of alpha, which come from the power of the exponential, and the value of n, which come from the polynomial in your function. But now you don't have any polynomial here. You actually have the polynomial x, but it's in the power of 0, because x to the power of 0 is equal to 1, so you cannot see the function. Okay, so from here we know that this is the value of n minus 1. Remember, the degree of your polynomial is always n minus 1, so n minus 1 equal to 0. Your n is equal to 1. So from here you get your n equal to 1, and your alpha is equal to 2. So what is your differential operator for your exponential function here? It will be d minus alpha to the power of 1, which is d minus 2. This is the differential operator, or we call as an annihilator operator. So if you are asking to find what is the annihilator operator for the function here, this is the answer. This is the way how to find it. Okay, let's see another example. Okay, let's see another example. Let's say if you have the question asks you to find a differential operator, or find the annihilator operator that annihilates the function y equal to exponent negative 3x. So you need to understand that if the function is only the polynomial function, without any other function, your operator will be d to the power of n, this one. But if it's exponential function, it will be combined with the exponent. It will be combined with the polynomial. Even though you cannot see the polynomial around here, but it's actually you have the x is with the power of 0. That's why you cannot see. Okay, so if you are asking to find what is the differential operator that annihilates this function, means that you need to use the formula of differential operator for exponent, which is d minus alpha to the power of n. So the value that is important for us to know, the first one is the alpha one, and the second one is n, where alpha come from the value in your exponent. Okay, and n come from the value of your polynomial. Now your polynomial is to the power of 0, and you need to know that this one is always n minus 1. Okay, equal to 0. Therefore, your n is equal to 1. Then you have the value of n already. So what is the value of alpha? Value of alpha is negative 3. You need to take together the sign of your value. Okay, then we put inside the formula here. So the differential operator is d minus alpha is negative 3 to the power of 1. So we have the differential operator is d plus 3. So this one is the differential operator that annihilates the function of y equal to exponent negative 3x. Okay, so let's see another example. Okay, if question asks you to find, question asks you find a differential operator that annihilates. Annihilates means the differential operator makes your function to become 0. Okay, the function 1 minus 5x squared plus 8x cubed. Okay, question asks you to find the differential operator that annihilates the function 1 minus 5x squared plus 8x cubed. And if you see in your function here is only a polynomial function, so we know that if it's only a polynomial function, the differential operator will be d to the power of n. We need to know the value of n. How to get the value of n? You need to see on your polynomial function here, what is the highest power that you have? It is 3, and this 3 is always n minus 1. Okay, so n minus 1 is equal to 3, so you have your n equal to 4. Therefore, d4 is the differential operator that annihilates your function here. What means the differential operator that annihilates the function? It means that this differential operator will transform your function to become 0 by the process of differentiation. We can try. We have y equal to 1 minus 5x squared plus 8x cubed. If we differentiate once, we have dy dx is equal to negative 10x plus 24x squared. If we differentiate twice, we will get d square y dx square is equal to negative 10 plus 48x. Okay, it's not yet 0. Differentiate again, then you will get d cube y dx cube as 48. Not check 0, and you differentiate again, you will get d fort y dx fort equal to 0. Okay, so this one can be transformed into differential operator as d to the power of 4y. Means that the differential operator d4 annihilates the function of y equal to 1 minus 5x squared plus 8x3, same as what you get here. Okay, so that's one example. Let's see another example. Okay, find a differential operator that annihilates the given function, which is 4 exponent 2x minus 10x exponent 2x. Okay, you no need to count how many function that you have. Okay, no need to count how many function that you have, but you only need to know what is the type of the function that you have here. So now in this function y, you only have the polynomial plus with the exponent. So we know if it's only a polynomial, the differential operator will be d to the power of n. But if it's a polynomial plus exponential, the differential operator will be d minus alpha to the power of n. So now you need to know what is the value of alpha and what is the value of n, where alpha come from the power of your exponent. So you can see here, both of your exponent has the same power, so there's no problem. If it's different power, means it's a combination of a function, but because of it have the same power, means okay, you have the same function. So now your alpha is equal to 2. What is your n? Your n come from the highest power of your polynomial. So here you have x to the power of 0, you cannot see. But here you have the polynomial x to the power of 1. And 1 is always the n minus 1. So your n is equal to 1 plus 1, your n equal to 2. So now you already have your alpha, you already have your n. So your differential operator will be d minus alpha, which is 2 to the power of n, which is 2. So this one is the differential operator that annihilates the function y equal to 4 exponent 2x minus 10x exponent 2x. Okay.